All right, so this is the Chapter 5 opener notes. That will help us with the Chapter 5 opener on big ideas. And the essential question for Chapter 5 opener here is, how can you use properties of integer exponents to simplify expressions? And how can you solve an equation for a specific variable? So the first thing we're going to need to look at for our core concepts here are our properties of exponents. So we have 8 different rules to follow. We have a product rule, which is when we have the bases are the same but to different powers, and the bases are multiplied together. We add the powers. Okay? Quotient rule is where I'm dividing. Then I subtract the powers, the top power minus the power in the base, or in the denominator, I should say it that way. Power rule, now I have something taken to a power, and all of that is taken to a power. So this is, I like to say this is a power to a power. It's not adding, because this is taking 2 different terms that both have powers and multiplying the terms together. This one is taking a power to a power, and that's when we multiply those powers. Okay, a negative rule. So if I have a variable or a number to a negative variable, the only thing that does is changes it to a fraction. Okay? So, especially if you do quotient rule and you do the subtraction and y was bigger than x, you'll often end up, if that's the case, you'll end up with a, like, let's just say I end up with an x to the negative 4th power. Well, then I need to come down and use the negative rule and end up saying, okay, then that means it's 1 over x to the 4th power. Okay? We don't leave it with a negative power. Power of a product. So this is saying I have 2 things multiplied together and all of that is taken to a power. Well, I just have to take each thing inside to that power. Power of a quotient, same thing. So even though this is a quotient here, but all of it is taken to a power, I need to take a power of the numerator, or the numerator to that power, and the denominator to that power. And obviously, the denominator cannot be 0, or you can't have a fraction there. Okay? This is my favorite rule, the 0 exponent rule. Anything to the 0 power equals 1. Anything but 0. 0 to the 0 power. No, doesn't work. But anything else to the 0 power equals 1. And then the exponent of 1. Anything to the first exponent, or 1 exponent, is itself. So that one I also like. These bottom 2 are kind of my favorites because they're easy to deal with. Alright, so if we now go to simplifying expressions using these properties, we have number 1. It is x to the 5th times x squared, all divided by x cubed. So let's list the powers that I'm going to need to use. At the top here, I have a product, so I'm going to use the product rule. And then this division is a quotient, so I'm going to have a quotient rule. And I like to clean things up. It doesn't quite matter what order you go in here, but I like to clean up the numerators and denominators before I deal with the quotient part. So I'm going to do the product property or product rule first, and then I'm going to do the quotient rule just to keep things nice and clean. Alright, so in the numerator, I have x to the 5th times x squared. Okay, so both of my bases are x. The powers are different, or even if they weren't different, you'd still treat this the same. So the base will stay the same, so no matter what, I'm going to have x to some power over 3x to the 3rd. So my powers on top are a 5 and a 2. And that product rule, so that number 1, says I'm going to I'm going to add those together to be able to multiply the x's, okay? So this ends up being x to the 7th over x cubed. Okay, so now we need to deal with our quotient rule, which is, if we go back to our quotient rule here, it's where we now subtract the powers. So I have x is the base, it's both bases, and it'll be the top minus the bottom power, okay? So this is number 2, that was the quotient rule. And then 7 minus 3 is 4. So in this case, it's a positive power. I only have x one time. I am done. Okay? So let's try number 2. This time I have some parentheses being taken to a power. So I can see that I'm going to have the power of a product, or like I like to say, I have powers of powers there. And everything inside, I need to first check, can I clean that up? And I can't. I have a 2. Well, there's no other number term there. I have s. Well, I only have that one s that's being cubed. And I have a t in the denominator. So that's as cleaned up as it can go. So to get rid of the parentheses now, we're going to take everything inside to the second power. Okay? So this is using the power of a product. I'm sorry, this is a power of a product and a power of quotient, because it's got the division. Okay? But on top, I have 2 is the power, and I have a term that is 2. So I'm going to have 2 squared. Then I have the term s cubed, and that is also squared. But when we do a power of a power, which is the power rule there, the power rule says I'm taking a power to a power. That's when I multiply them. So it's 3 times 2. And then in the denominator I have t, and really its power is 1. So I'm taking it 1 times 2, which is 2. Okay, and let's just clean this up. 2 squared is 4. S, and then the power is 3 times 2, which is 6, all over t squared. Nothing else can simplify. I don't have a negative power. Okay, I don't have any other constant terms or number terms. I don't have more than one s or more than one t. So this is as simplified as it gets. So for all of these, you're going to review your rules. You want all of your answers to end up with positive powers, no zero exponents, no variable more than once, okay? All of those. So now you can go to your practice and do 1 through 6 and then continue on to the next video.